Hey, Erica, this is the first part of functions. We are starting chapter 3 today. Here we go. No homework out of the book. You guys have the worksheet already. It's there for you. There you go. Example 1, determining inputs and outputs. As far as x's and y's go, which one is the input typically? The x and the outputs are the y's. They also call the x the independent variables, right? So independent. Okay, and then they say after you plug x in, the y depends on what x you plug in, right? So y is the dependent variable. Okay, the output value depends on what you put in for your input value. Okay, so describe this set of inputs, this set of outputs, and the rule for the following functions. All right, so A says the amount of income tax you pay depends upon your income. Okay, so in that, what is the inputs and what is the outputs? The amount of tax you pay depends upon your income. The income is your input. Okay. Okay, and then tax amount is your output. Right? Okay, and then what else do they want? And the rule for the following functions. Like the rule would be like, I don't know, income, or let's do this. Let's do tax equals income times, let's go the rate. So whatever the tax rate is, that would be like the rule for that scenario, okay? The amount of money you pay in taxes is your income times the rate of the tax rate, okay? All right, the second one, suppose a rock is dropped straight down from a high place. So I'm up on a hill and I drop a rock straight down. Physics tells us that the distance traveled by the rock, t, rock in t seconds is 16 t squared. So I'm gonna start with the rule. They're saying distance is equal to 16 t squared. Okay. Do you guys remember what that 16 stand for? What is 16?
Acceleration due to gravity.
Acceleration due to gravity in feet per second squared, right? Okay. So 9.8 meters per second squared, which is what you're used to hearing in physics and Mr. Moose classes. That is the equivalent of 16. So here is the scenario that we have. This is the rule. Okay. Let's talk about the inputs now. Okay. So input and output, or the independent and dependent. What's the input amount? Amount? What am I inputting into this thing? What? The what? Time is my input amount. Okay. So I'm saying after how many seconds, the output is how high we are. Like how high the rock is, right? So the distance is the output amount. I can find the distance based upon how long the rock has been falling, or the height based upon how long the rock has been falling. Good? All right, last one. I think this has to do with the graph over here, in which case we won't really have a rule because this is not an actual y equals something function. The rule is basically the graph. So this entire thing is the rule for temperature. Okay. So we're talking about temperature. The Weather Bureau records the temperature over a 25 or 24-hour period. The graph shows the temperature that corresponds to each given time. All right. So it is the warmest at about 1500 hours, which is what time?
3 o'clock.
3 p.m., right? Okay. About 3 p.m. and it gets up to about 65 degrees-ish. Okay, what is my input values and what are my output values?
What? 3 p.m. or
time is your input, and the output value, what depends upon the time, is the temperature. Okay, so temperature is dependent upon the time of day. Time is your input, or your x coordinates, your y coordinates are your temp. Right? Okay, good. Not too bad. Inputs, outputs. Definition of a function, we have domain and range, which is what we'll talk about. The domain refers to the x's, the range refers to the y's. We've done domain and range already, I think. Okay? All right. Determine whether a relation is a function. The table below shows the inputs and outputs of two relations. Determine whether the relation is a function or not a function. A, yes or no? No, how's come? The ones and the threes. This is not a function. No. B, function or not a function? Yes, but I see 2 5s. Those are the y's, so it doesn't matter. Yes, this is a function. Yes, function. Okay, happy with that? We know that already, right? X's can't repeat, but the Y's can. Okay. Now you'll have a lot of these on your homework assignment where it says evaluate the function, find the answer, right? Okay. And when there is a square root involved, if your square root does not come out nicely, don't evaluate it as a decimal. Just leave it as the square root. Did you hear me? Kyle, did you hear me?
What?
If when you put a number in and it's a square root, if it does not come out nicely, like the square root of 11, don't give me the decimal number, just leave it as the square root of 11, okay? All right, so here we go. So here we're plugging 3 in, right? We're plugging 3 in, and 3 goes in for x. So we have the square root of 3 squared plus 1. That is the square root of 10. Does it come out nicely? No, so we just leave it as the square root of 10, okay? Next, when we plug in numbers, we always need to make sure, I didn't do it on the last one, so I did bad. You need to make sure that they are in parentheses, because if I do negative 5 squared in parentheses, that becomes positive 25, right? If I don't put parentheses, it's actually a negative 25. So we always plug stuff in parentheses. This is 25 plus 1, which is the square root of 26, which doesn't come out nicely. I don't even think you can break it down. That's 2 and 13, which doesn't work. So we'll leave it as the square root of 16. Okay, last one. The square root of 0 squared plus 1. That is the square root of 1. Does that come out nicely?
Yes.
Yes, what's the square root of 1?
1.
Is it plus and minus 1 or just 1?
Plus or minus. Plus minus.
Just one. You have a negative in the square.
But when you take the square root of something, isn't it always plus and minus? It's only plus and minus if we put the square root in there. This square root already existed, so we pretend that there's an imaginary plus sign in front of it, okay? So if the square root is already existing, we assume that it's just the positive of whatever square root it is. The time where we take the square root is like when we have like x squared equals 4, we are inserting the square root in there. So I don't know if that's plus or minus, okay? But if the square root's already there, we assume it's positive. So it's just 1. Okay, happy with that? Good, good? Okay, this next part. It's been easy so far. This next part is the hardest part, okay? It is something called calculating the difference quotient. This is the definition of derivative. Definition of finding a derivative. Okay, now we find derivatives in calculus all the time. Okay, the difference quotient is what you calculate when you're finding the derivative. Now, we have in calculus, we learn like really simple ways of finding the derivative, but this is finding it using the definition of derivative, okay? So, just FYI, A, B, C, they have baby stepped it for you, so each part, this is actually the difference quotient right here. Like if they ask for the difference quotient, they want you to calculate this entire thing. But that's kind of, it's like 3 pieces in one, right? So what they've done is rather than calculating that whole thing, they're saying in part A, just do this part. In part B, now do the top part. In part C, now divide that all by H, right? So they're baby stepping you through it. But when they ask for the difference quotient, they're saying find part C, basically, is what you're trying to get to, okay? And so this is the definition of finding a derivative, which is what we do in calculus, okay? Now, after this problem, you 3 boys, don't be scared, because I can find a derivative not by using that, by doing a really easy thing. Like if I look at this thing, I can tell you that the derivative of that thing is 2x minus 1. That's the derivative. That's the answer. That's what we're going to get to at the very end, okay? And you'll see that using the definition, we will get to that answer. But I can calculate that like just with my brain, and so don't get discouraged because it will not always be this hard. Derivatives are like super easy to calculate. All right, so difference quotient, we're going to do piece by piece, and this gets really ugly because my function is really ugly to begin with, okay? So x squared minus x plus 2, they are saying plug in x plus h into the x's, both of them, okay? So I'm plugging in x plus h in there, all right? Ready? X plus h squared minus x plus h, and then plus 2. That's that first part. Do you see how that works? We're plugging that in, and we're going to solve, and we're going to simplify it, okay? Do you see how I plug that in? Plug those in for h, or for x,
Could you say that
okay?
one of them goes away with the when you subtract it or no?
We will have a bunch of stuff cancel out, yes, but we've got to FOIL this first before we subtract. Okay, we've got to FOIL this thing out first. So I'm going to go over here to the side, and I'm going to do x plus h times x plus h, okay? And we're going to FOIL this, okay? Because h is not a number, it makes it kind of weird, okay? So x times x is x squared, yeah. X times h, how do you want to write that? xh. I'm going to go hx, doesn't matter, xh, hx, whatever, okay? Plus another hx plus h squared. Now these two, I have two hx's, so I have plus 2hx, right? So I have x squared plus 2hx plus h squared, blah, 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 right? Good? Are we happy with this so far? Kind of? Like not happy, but like we'll live, right? So this guy becomes x squared plus 2hx plus h squared. Okay, now the next piece is this chunk right here. And I'm going to distribute the negative through, right? Negative, negative. So minus x minus h plus 2. Do you see how that works? So this right here is part A. As ugly as that is, I don't think there's anything we can combine yet. There's nothing that we can combine yet. Okay? Good? Happy with that? All right, so that is part A. Part B says we want f of x plus h, which is what we just calculated. That's that part, minus f of x, right? Minus f of x. So I'm going to take this thing and I'm going to subtract f of x. What is f of x?
It's x squared minus
The original, right? I'm going to subtract x squared minus x plus 2. Do you see how that works? Yeah? I'm going to subtract that, okay? So I'm going to take all of these things, I'm going to subtract that. But before we subtract, let's distribute the negative. So minus x squared plus x plus 2. And let's start combining things, okay? So x squared minus x squared.
Wouldn't it be minus 2?
Minus 2. You're correct. I can't math. X minus 2. Thank you. Okay. So the x squareds go away. You see that? Okay. This 2xh does not go with anybody. So I'm going to write 2xh or 2hx. Whatever. Whichever order you put them in. 2hx. Okay. Good. So he's done. H squared. Does he go with anybody? No. So plus h squared. Okay. What about minus x? Plus x. Gone. Okay. Minus h. Doesn't go with anybody. So we put minus h. And then plus 2 minus 2. Gone. Okay, so that stuff all simplified to be this. That cancels out really nicely. Really super nicely. Okay, good? Happy with that? All right, now the last piece says, now take that all and let's divide by h. Okay, take that all and let's divide by h. So each one of these three pieces has an h in it, correct? Okay, so let's just take an h out of all three pieces. So on the top, all that's left over is 2x, right?
Yeah.
Plus h minus 1. Okay, now I'm going to switch that around and I'm going to call it 2x minus 1 plus h. I'm going to put the plus h on the bottom. Okay, now this is our difference quotient. Okay, this is our difference quotient. All right, that was a lot of work. This is the definition of finding a derivative. Now, I told you before, you three boys, that your derivative was 2x minus 1, right? We have an extra h on the end. So the last piece of that is you plug 0 in for h, okay, which is 2x minus 1.
But it says h can't be 0.
Okay, well, okay, yes, I see where you're getting at. You technically,
You can't have 0.
you plug 0 in for h, but it has to do with it being a limit. So you're not plugging 0 in for h, you're finding the limit as h goes to 0. So it's like essentially plugging 0 in for h, but h is not 0 exactly. Does that make sense? No,
That's
not really.
stupid.
Okay, so it has to do with a limit. Okay,
So it is
So
0,
it's-
but it isn't 0?
so it's
It's
the
like a stupid open circle and like the
mhm.
number line.
So
It's
it
not
is
0,
the
but
limit
it's
as
plus 0.
h goes to 0 of this thing, which actually ends up being 2x minus 1.
Poor Erica, she's probably like not even on the
Whatever.
continent.
Anyway, so don't worry about that last piece, but this is the difference quotient, that whole thing, plus the h included, okay? But we go one step further in calculus where we actually plug 0 in and we get it as a derivative, okay? So yes, h can't be 0, but as h approaches 0, it will end up being 2x minus 1. Confusing. I get it. We'll get to that, okay? We're not to that point yet, okay? Good? There you go.
Good for the day?
Yay! Let's go do one.
That was a
Let's do
lot.
example 5 because then we're stop at domain convention.
No, we stopped
Yeah.
at it. Because we need to refresh our brains on Monday.
Example 5 is a good one. It's easy.
But we'll need to refresh our brain.
No. Example 5, determine whether it defines a function. Okay? Determine whether each equation defines y as a function of x. Okay? I have an x and I have a y to the third power. X and y to the third power. Do you know what y equals x to the third power looks like?
Yeah, it looks like a that thing.
It looks like one of these things, right? Okay? So do you know what x equals y to the third power is?
Flop it.
It's like this. It's like the cubic root, which is actually what it would be if you would take the cubic root, right? So is that a function?
Yes.
How do you know that?
Because you pass the vertical.
Because it passes the vertical line test. It goes like that. Okay? Now, this one is y squared and x, right? So if I flop that around and I say, okay, what about y equals x squared? Do you know what that looks like?
I was gonna throw it. Yep.
A parabola, right? What's x equals y squared look like? A sideways parabola. Okay, now, also, Jalen's like, how do you know this? Okay, let's say I'm solving for y, right? Let's say I'm trying to get y by itself, okay? Let's add these to the other side. No, you're fine. Because, like, it's totally legit. Like, I don't believe it either, right? If I subtract those to the other side, I get x minus 1, right? And then I take the square root of y, right? Okay, so y equals plus and minus the square root of x minus 1, right? Do you know what a square root looks like?
Just like a little.
It starts like this, right? Do you know what a negative square root looks like? The other way. So it's basically like finding, like, this is the same thing as x equals y squared, right? Like, the minus 1 is going to move him. Yes, I agree with that, whatever. So he's not moved yet. But that's kind of how, like, the reason why he ends up being a sideways parabola, because it's actually a plus and minus square root. Yeah? So,
Just plug this in my calculator and then do it that way.
it would be nice if you could, but you have to have y solved for in order to do that. So, yeah, if you get y solved for and you plug in plus and minus the square root of x minus 1, you can. Yes. Yeah, so that's the only tricky thing about it. So, not a function for b, but yes, a function for a. Okay? Good? Makes sense? Ish. All right, we'll stop there. Okay? All right, you guys have quite a bit on the homework assignment that you could start on. If there's 19 questions total, so it is a little bit longer, but most of them you're just plugging in and stuff, so you can get a start on that. Okay? All right, goodbye, Erica. Wherever you are. I don't know how I can get it to come up.